Good morning to all. Welcome to the ninth online lecture of sampling methods. In this lecture, we are going to see the determination of sample size. Now, suppose we had decided to use simple random sampling with replacement or simple random sampling without replacement. Any one method for our study. Then, what will be the sample size which represent the population? How many samples we have to take so that sample must be the representative of the population. So in this lecture we are going to see the determination of sample size. First definition is definition of marginal error. So marginal error is actually mod of statistic minus parameter. Now statistic means function of sample observation. So this is obtained from sample and parameter is population characteristic. This means this may be a population mean, population variance or population standard deviation like this. So the difference between parameter and its estimator is statistic. This modulus difference is called as marginal error. Relative error. Relative error definition is statistic minus parameter upon parameter and mod of this quantity. Next definition is coefficient of variation. Usually coefficient of variation is denoted by sigma by mod of y bar into 100. So this coefficient of variation represented in percentage. But we are going to see this coefficient of variation which is not in percentage. Here sigma is replaced by s. When your n is very large, capital N is very large, then this sigma means population standard deviation and population root mean square not makes any difference. So coefficient of variation formula will be s by y bar. Now look at this theorem. Under SRSWR, derive an expression for sample size to estimate population mean. Means here we want to estimate a population mean so as to meet the specified marginal error. So marginal error is specified and confidence coefficient. So proof of this theorem. Here we have to find n such that probability of mod of y bar minus capital Y bar less than d is equal to 1 minus alpha. Here we have to find population mean. We have to estimate a population mean. So this is your parameter, and this parameter is estimated by using this statistic. So sample mean is an estimator of population mean. So as to meet the specified marginal error means the marginal error definition is like the statistic minus parameter. This is specified means this is less than d. This d is given. And confidence coefficient means here we are confident 100 into 1 minus alpha % confident that this probability of this mod y bar minus capital Y bar is less than d. So confidence coefficient means this one. Now, you know Expected value of small y bar is under WR method is yes or yes WR. Expected value of small y bar is capital Y bar and variance of small y bar is, this is actually sigma square by n. You know this formula, but we have to write here formula in terms of S square, population mean square. So in terms of population mean square, formula is like this: n minus 1 n S square. So if expected value of y bar is capital Y bar, variance of y bar is this one, so we can say y bar follows normal, asymptotically normal with capital Y bar. Its mean is expected value of y bar is capital Y bar, so its mean is y bar and variance is this one. So this is asymptotically, we can say approximately. So convert this into standard normal. So how to convert this in standard normal? So y bar minus its expectation capital Y bar upon its standard deviation. Its standard deviation is n minus 1 upon n S square. This follows normal 0. So look at this. So divide here by root of n minus 1 upon n into S square. So after dividing this by y bar minus y bar upon root of n minus 1 upon n S square, this is less than d upon root of n. No need to write mod here because this quantity is variance and variance is always positive. So here we had written mod, so here no need to read mod because it is a greater than 0 quantity and mod for greater than 0 quantity is that quantity itself. So root of n minus 1 upon n S square is equal to 1 minus alpha. So this is your z because we denote this standard normal variable by z. So this implies probability of mod z less than d upon root of n minus 1 upon n S square is equal to 1 minus alpha. So here z follows normal 0 1 standard normal variable. So we know this thing. Probability of mod z less than z alpha by 2 is equal to 1 minus alpha, where z follows normal 0 1. So compare this with this one, then we get d upon root of n minus 1 upon n S square is equal to z alpha by 2. So I can write this as root n, there is a d into root of n minus 1 S square is equal to z alpha by 2. Now this implies take square on both sides. After taking square, this will be d square n upon n minus 1 S square is equal to z alpha by 2 square. We have to find small n sample size. So send all these quantities in this side. So this will be n is equal to n minus 1 S square z alpha by 2 square divided by d square n. So I can write this as this n minus 1 upon n as 1 minus 1 upon n, and this remaining quantity is as s into z alpha by 2 by d whole bracket square. So this is the formula for n. So sample size, when we want to estimate a population mean y bar, then and method is SRSWR, then we can obtain the sample size by using this formula. Z alpha by 2 is obtained from table. D is given, S is given, capital N is known. Then put all these quantities, then you will get the sample size. Now we will going to see one remark. If n is not given, means sometimes population size is not given. So we assume that in that case, if n is not given, we assume that n is very large than small n. So then, if n is very large means suppose it tends to infinity. If n tends to infinity, then 1 upon infinity will be 0. So 1 minus 0 becomes 1. In that case, n will approximately equal to s into z alpha by 2 by d square. So when n is not given, capital N is not given, we can find the sample size by using this formula. Now look at this theorem. Here only change is under SRSWR. So under SRSWR without replacement method, derive an expression for sample size, means we have to find small n to estimate population mean. So again, to estimate population means so as to meet the specified marginal error and confidence coefficient. So proof of this theorem, to find n such that probability of specified marginal error means mod of y bar minus capital Y bar less than d, and confidence coefficient means this one. Under SRSWR, we know SRSWR, expected value of small y bar is capital Y bar. This means sample mean is an unbiased estimator of population mean, and variance of y bar, formula for variance of y bar is n minus n upon n minus 1 sigma square by small n. So this same formula in terms of S square, population mean square, is n minus n upon n S square. Alright. Now, if expected value of y bar is this one and variance of y bar is this one, so we can say this small y bar follows normal, asymptotically normal with capital Y bar, comma, n minus n upon n into S square. Now convert this into standard normal. So we can convert this into standard normal by y bar minus its expectation divided by its standard deviation. So n minus n upon n S square. This follows normal 0 1. Usually we denote this by z. Now by using this, here we can convert this quantity into z by dividing it by its standard deviation of this y bar. So probability of, we can write this as mod of y bar minus capital Y bar upon root of n minus n upon n S square is less than d upon root of n minus n upon n S square is equal to 1 minus alpha. So this is your z. So we can write this as probability of mod z less than d upon root of n minus n upon n S square root is for s square also, which is equal to 1 minus alpha. When z is standard normal variable, then probability of mod z less than z alpha by 2 is equal to 1 minus alpha. So compare this with this one, then we get d upon root of n minus n upon n into s square is equal to z alpha by 2. We can write this as d into root n upon root of n minus n into s square is equal to z alpha by 2. Take square on both sides. After taking square on both sides, this will be d square n divided by n minus n s square, which is equal to z alpha by 2 square. Now we have to solve this equation for small n. So we can solve this like this: d square n divided by, here it will be n s square minus small n s square into z alpha by 2 square, which is equal to z alpha by 2 square. Now send this quantity in this side. So this will be d square n which is equal to n s square z alpha by 2 square minus small n s square z alpha by 2 square. Now send this quantity in this side. So this will be d square n minus, it will be plus n s square z alpha by 2 square, which is equal to n s square z alpha by 2 square. Now from these two quantities we can take small n common. So take small n common, this will be d square n plus s square z alpha by 2 square is equal to n s square z alpha by 2 square. Now we can send this one in this side, then we will get small n. So some small n is equal to n s square z alpha by 2 square divided by d square n plus s square z alpha by 2 square. Now divide numerator and denominator of this side by d square by n. So if we divide this by d square by n, and here also if we divide by d square by n, then we will get, here n capital N gets cancelled. This I can write s z alpha by 2 by d whole bracket square whole divided by this divided by, if I take d square by n here, then this will become 1 plus, if I take d square by n here, so I can write this as 1 upon n into s z alpha by 2 by d bracket square. So this is the formula for sample size when we want to estimate population mean and for a specified marginal error, and method is SRSWOR. Remark: if n is not given, if capital N population size is not given, many times it is unknown, then we assume capital N is very large than small n, then the formula for small n is, if capital N is very large means it tends to infinity, then this quantity becomes 0, because 1 upon infinity we say it becomes 0. So this is 0, so 1 plus 0 becomes 1, and then the approximate value of n will be s into z alpha by 2 by d square. So under SRSWR also this formula is same when capital N is not given. So when we have to use SRSWR or SRSWOR and capital N is not given, they use this formula to calculate a sample size. Thank you.